Yes, the recording is started. You can write your roll numbers in the chat box now. Am I audible?
Yes, sir.
Okay. Right. So before I start, let me announce today we have organized one guest lecture on Internet of Things. More specifically, in that the expert lecturer will talk about home automation by using IoT. So this guest lecture is organized at 4 o'clock, right? So everybody must join this, and let me tell you, the attendance will be recorded and it will be considered in a regular attendance of IoT, right? So this is what the policy that we have. Guest lecture attendance will be considered in the attendance of regular lectures. So everybody must attend. If you fall, you will be on a loss of 2 lectures, right? So since it is going to be there for 2 hours from 4 o'clock to 6 o'clock, right? So everyone must attend that with what I can say, 100% alertness. Some industrial exposure is going to be there, so that's why it is important. Right, so let's begin for today's lecture. So what I have planned is, so if you see the syllabus, so this instruction set I'm going to discuss completely in tutorial section. Right, so I guess some of the basics of exception handling, etc., I have given to you. Still, we will discuss those things like exception handling. Then we will discuss low power features, requirements, then sleep modes, whatever are there supported in Cortex M3. Then development of low power application, right? So these are the things that I'm going to discuss today. Let me copy this thing and let me paste it here so that you will have this agenda in your mind, what things are going to be discussed. Right, so few points I have listed here: exception handling, low power feature, requirements, then sleep mode, and development of low power features. So let's begin with the first point. But let me tell you, there are two kinds of handling. One is exception handling and one is interrupt handling. So I'm going to clear the difference between those two. The difference is not so much, I can say. Exception and handling, they both, exception and interrupt, they serves for say a similar purpose, right? So whenever exception is occurred, you have to entertain it, you have to handle it. Whenever the interrupt is occurred, you have to handle it, right? So the processor should be trained to handle the exception or interrupt upon arrival, right? So in the interrupt driven processing environment, we can differentiate between two types of interrupt event. It may be internal or external, right? So for exception, we can have the interrupt, it may be internal or external, right? So both of the event cause the program flow to exit the current program thread. It may switch to handler mode, right? So this is what called as the exception. In short, with reference to this diagram, I can tell you. See, this is the exception handling diagram. You can observe this is a thread mode, right? So upon reset, your processor would be in a thread mode, right? So it would have a thread mode. For a while, let us forget about the privilege levels. these are the two operating modes of Cortex M3, right? And first one is thread mode and second one is handler mode. So upon reset means what? When you press the reset, your processor will be in this thread mode and it will be executing the normal code sequence. Meaning of that, it will be executing the main program. Main program means what? Main program is intended here to save the power, राईट. तुम्हाला वाटत असेल की मेन प्रोग्राम म्हणजे वेगळं काहीतरी असतं, नाही. मेन प्रोग्राम मध्ये आपण प्रोसेसर स्लीप मोड मध्ये टाकतो. बेसिकली वी पुट आवर प्रोसेसर इन अ स्लीप मोड ड्यूरिंग दिस मेन प्रोग्राम एक्झिक्युशन. का? रिझन बिहाइंड इज वी हॅव टू सेव्ह द पॉवर, वी हॅव टू कॉन्झर्व द बॅटरी. And hence executing normal sequence means we are trying to keep the processor in a sleep mode and we are trying to save the power. आता त्यानंतर जर एखादा इव्हेंट आला म्हणजे सपोज यू हिट सम की ऑन द कीबोर्ड और सपोज यू hover the mouse or suppose you click left or right click on the mouse. So in that case the external or internal event may occur. Now these are the cases of external event. कीबोर्डवरची की प्रेस करणे किंवा माऊसवरचा क्लिक प्रेस करणे, दीज आर एक्सटर्नल इव्हेंट्स. What are internal event? Collision of data, right? Collision of data means let's say bus collision. This may be an event. You have to detect it. You have to entertain that event. This is the internal event, right? So the events can be internal or external. And upon arrival of that internal, your processor should leave that thread mode. म्हणजे त्यांनी स्लीप मोड एक्झिट केला पाहिजे, right? So your processor should leave that thread mode and it should enter into the handler mode, right? So upon arrival of that internal event or external event, you have to save the content of program counter in the link register. This is what the reason called as it is a context saving. You are saving the context of main program. म्हणजे जिथं मेन प्रोग्राम एक्झिक्युशन स्टॉप केलंय ते कॉन्टेक्स्ट आपण सेव्ह करायचे लिंक रजिस्टर वरती, राईट. सो अपॉन अरायवल ऑफ इंटरनल और एक्सटर्नल इव्हेंट द कॉन्टेक्स्ट सेव्हिंग इज डन and your processor will exit, it will leave this thread mode and it will enter into the handler mode. आता हँडलर मोड कशासाठी? जो काही इव्हेंट आलेला आहे त्याला हँडल करण्यासाठी आपल्याला तो प्रोसेसर हँडलर मोड मध्ये पाठवावा लागतो. दिस इज व्हॉट कॉल्ड एज अ हँडलर मोड. नाऊ लेट्स से कीबोर्ड वरती एखादी की प्रेस केलेली असो किंवा माऊस वरती एखादा क्लिक प्रेस केलेला असो, corresponds to that whatever action is required is written here in the handler mode. याला म्हणायचं आपण हँडलर मोड. आणि ती ऍक्शन त्या ठिकाणी घेणे म्हणजे हँडलर मोड किंवा त्याच्यामध्ये म्हणतो आपण एक्झिक्युशन ऑफ एक्सेप्शन हँडलर. ऍक्शन इन विच द एक्सेप्शन इज एंटरटेन्ड इज कॉल्ड एज अ एक्झिक्युशन ऑफ एक्सेप्शन, राईट. त्यानंतर ती ऍक्शन म्हणजे एखादा की प्रेस केल्यानंतर असेल किंवा माऊसवरचा क्लिक प्रेस केल्यानंतर जी काय ऍक्शन असते ती ऍक्शन झाल्यानंतर तो प्रोसेसर कॉन्टेक्स्ट रिस्टोअर करतो. कॉन्टेक्स्ट रिस्टोअर करतो म्हणजे काय? जे लिंक रजिस्टर वरती या कॉन्टेक्स्ट सेव्हिंग मध्ये जे कंटेंट सेव्ह केलेले असतात दोज कॉन्टेक्स्ट those addresses will be returned, it will be taken back onto the program counter so that your program counter may know where to start in the main program. This is what called as a finishing handler. इथून ज्यावेळी प्रोसेसर बाहेर पडतो त्यावेळी तो मेन प्रोग्रामला जातो, त्याला म्हणायचं फिनिशिंग हँडलर. I guess now it is clear what is exception. Exception is nothing but internal or external events, right? So in addition to that, when the processor is finishing this executing the exception handler, it will return to interrupted program and resume the original task. This is how the exception is handled. The status of interrupted program should be noted in case of interrupted event. the information is then restored from the exception handler, right? So this will ensure that the processor can resume its original task in the thread mode. So this is all about the exception handling. ज्यावेळी रिसेट आपण रिसेट करतो, प्रोसेसर या थ्रेड मोडमध्ये असेल, इंटरनल किंवा एक्सटर्नल इव्हेंट आला तर तो कॉन्टेक्स्ट सेव्ह करेल, म्हणजेच प्रोग्राम काउंटरवरचे कंटेंट लिंक रजिस्टरमध्ये जातील आणि तो हँडलर मोडमध्ये जाईल. हँडलर मोडमध्ये तो इव्हेंट एक्झिक्यूट केल्यानंतर तो परत बाहेर पडेल आणि परत बाहेर पडताना तो जाणार आहे थ्रेड मोडमध्ये, म्हणजेच कॉन्टेक्स्ट रिस्टोर होतील, म्हणजे लिंक रजिस्टरवरचे कंटेंट आता प्रोग्राम काउंटरला जातील आणि त्याला म्हणायचं आपण फिनिशिंग हँडलर, अँड इट विल अगेन गो बॅक टू द थ्रेड मोड. हे लूप जे आहे ते इन्फायनाईट लूप असतात. एखादा इव्हेंट आला की तो हँडलर मोडमध्ये जाईल, इव्हेंट एक्झिक्यूट केला की परत तो थ्रेड मोडमध्ये येऊन थांबेल. So this is being followed for every electronic gadget that you know. तुमचा मोबाईल असेल, 30 सेकंदानंतर तुमचा मोबाईल स्क्रीन ऑफ होते, बरोबर आहे. त्यानंतर तुम्ही डबल टॅप ऑप्शन वापरता, डबल टॅप स्क्रीनवरती केला की वेकअप होतो, म्हणजे हँडलर मोडमध्ये जातो. परत 30 सेकंद जर ऍक्टिव्हिटी डिटेक्ट नाही झाली तर तो परत थ्रेड मोडमध्ये, म्हणजे त्याचा स्क्रीन ऑफ करतो. This is how every electronic gadget works. Next part on this is, as I said, interrupt handling, and what is difference between exception handling and interrupt handling. Only the change is exception handling is done when the interrupt request is arrived. आपल्याकडे 240 interrupts आहेत, which you can make which you can use for several purposes, right? So interrupt request, upon arrival of interrupt request, this processor will leave this thread mode and it will be entered into the handler mode by doing the same thing which has been done in the previous case. Context saving इथं पण होणार आहे. Context saving होणार आहे म्हणजे काय? The content of program counter will be stored on a link register, and upon arrival of this interrupt request, processor will enter into the thread mode. Here in this thread mode it will execute ISR. ISR means what? Interrupt service interrupt subroutine. ISR means interrupt subroutine, right? So interrupt subroutine, when this interrupt service subroutine is being executed, this handler mode will be provided with privileged access of memory, just like you might have created some interrupts in 8051. तुम्ही त्या ठिकाणी INT0 INT1 आहे, ठीक आहे. INT0 INT1 त्याच्यावरती एक बटन कनेक्ट करता, ते बटन प्रेस झाल्यानंतर एखाद्या पिनला जोडलेला LED 10 वेळा ब्लिंक होईल, ठीक आहे. सो ब्लिंकिंग ऑफ that LED 10 times, this is written in this ISR. एखादा बटन प्रेस केल्यानंतर त्याच्या करस्पॉन्डिंग कुठली ऍक्शन परफॉर्म होणार आहे, that action is defined in ISR. After performing that action, it will again go back to the thread mode by using this context restoring. त्यालाच म्हणतो आपण finishing the handler. So what is the difference between exception handling and interrupt handling? The difference is very small. I can go back and I can tell you, the exception handling is done when the internal or external event is occurred. The exception handling is done when internal or external event is occurred. And interrupt handling is done when the interrupt request is occurred. Interrupt handling is done when interrupt request is arrived. Getting? So I guess these two concepts are clear. Very small difference between those two things. Otherwise, the rest of the things are same. I guess this one, exception handling, is done now. Low power feature. Next point is low power features. So I can give the heading here. Low power features. right? So let us discuss what is low power feature. So what do you mean by low power feature, or how this Cortex M3 is trending? Why this Cortex M3 is trending? So these are the features that the Cortex M3 possess. Number one, two architectural sleep modes. Two So the first feature that Cortex M3 has. This is the first low power feature that the Cortex M3 has. Now, what do you mean by sleep mode? I told you for having a low power application, your processor must be in a sleep mode all the time. Whenever interrupt or exception is occurred, it should go to the it should leave the thread mode and it should be entered to handler mode, right? So there are two sleep modes supported in a Cortex M3. In that, number one, it's a normal sleep mode. It's a normal sleep mode. I'll tell you what is normal sleep mode. And second one is it's a deep sleep mode. So Cortex M3 supports these two kinds of sleep modes. That's why it is very much trending for low power applications, because Cortex M3 is the only uh, device that support two different types of sleep modes. Means what? You can have the option to go in a sleep mode. What kind of sleep mode you have, your processor should be entered into. So based on the functionality, baga, normal sleep, as usual, you can as the name implies, normal sleep means it will save the power, and deep sleep means it will be saving more and more amount of power, right? So I'll come back to these two concepts later on while discussing the sleep modes, but keep it in mind, one of the highlighting feature of Cortex M3 is having two architectural sleep modes, right? One of them is normal sleep and the second one is deep sleep mode. Next feature that the Cortex M3 possesses is two instructions for entering into the sleep modes. Two instructions for entering into the sleep mode. Now, just now I told you there are two sleep modes. Similar to that, we have two uh, different instructions to be entered into the sleep mode. In that, first one is WFE. WFE stands for wait for event. हा वेट फॉर इव्हेंट कधी वापरायचा, आणि सेकंड वन इज वेट फॉर interrupt, WFI, wait for interrupt. Just now I told you there are two types of handlings. One is exception handling and one is interrupt handling, right? एक्सेप्शन हँडलिंग करत असताय त्यावेळी तुम्ही ही वेट फॉर इव्हेंट इन्स्ट्रक्शन एक्झिक्यूट करायची, म्हणजे इव्हेंट ऑकर झाला की तो एक्सेप्शन हँडलिंग मध्ये जाईल, अदरवाइज इट विल रिमेन इन अ स्लीप मोड. आणि WFE केव्हा वापरायची, WFI केव्हा वापरायचा, जेव्हा तुम्ही इंटरप्ट हँडलिंग करत असता त्यावेळेला ही WFI इन्स्ट्रक्शन एक्झिक्यूट करायची. म्हणजे काय, जेव्हा इंटरप्ट येईल त्यावेळी प्रोसेसर थ्रेड मोड मधून हँडलर मोड मध्ये जाईल, इंटरप्ट एक्झिक्यूट झाला की हँडलर मोड मधून बॅक टू थ्रेड मोड, राईट? सो थ्रेड मोड म्हणजे मी सांगितलं तुम्हाला, मोस्ट ऑफ द टाइम इन द थ्रेड मोड युअर प्रोसेसर विल बी इन अ sleep mode in order to save the power. So first highlighting feature, it possesses two sleep modes. Second highlighting feature is it's having two instruction for entering into the sleep mode. म्हणजे तुमच्याकडे दोन वे आहेत to get entered into the sleep mode. Wait for event, wait for interrupt. Right? Next one is sleep on exit feature. Sleep on exit. Sleep on exit feature. Right. So all the processors to stay in a sleep mode make use of this sleep on exit feature. Right. So it will allow the processor sleep on exit. So it will allow the processor to stay in a sleep mode as much as possible. म्हणजेच काय, जोपर्यंत एक्झिट ऑप्शन येत नाही तोपर्यंत तो स्लीप मोड मध्येच राहील. टू गिव्ह अ लिटल मोर क्लॅरिटी ऑन दॅट, I can say that this is another best feature that is supported in Cortex M3. So it can be programmed to go back to sleep mode automatically after interrupt subroutine is exit. म्हणजेच काय, तुम्ही एकतर एक्सेप्शनची वाट बघत असतात, or you are waiting for interrupt. Right? So after handling exception or the interrupt, when you exit this exception handler or when you exit this interrupt handler, it will again go back to the sleep mode. This is the feature that the Cortex M3 possesses. Sleep on exit म्हणजेच exception handler exit होतो किंवा इंटरप्ट हँडलर एक्झिट झाला म्हणजेच काय, एक्सेप्शन किंवा इंटरप्ट कम्प्लिटली एंटरटेन करून तो हँडलर एक्झिट झाला की तो परत स्लीप मोड मध्ये जातो. इट्स अ कंटिन्युअस प्रोसेस. राईट, इट इज अ इनफायनाइट प्रोसेस, आय वुड से. So when these handlers exit, it will automatically enter into the sleep mode. So this is the feature supported in almost every ARM processors. So the same feature is written here for Cortex M3 as well. So sleep on exit. Handler exit झाला की परत तो प्रोसेसर sleep mode मध्ये जाईल. Right? So this is simple meaning of sleep on exit. Next one is wake up interrupt controller. Wake up interrupt controller. So this is WIC in short. Long form of this is wake up interrupt controller. Right. So this is another feature that is supported in a Cortex M3. What is meaning of this wake up interrupt controller, or what is the functionality of this WIC? This wake up interrupt controller is an optional feature that is provided in Cortex M3. Means what, you can decide whether to use this WIC or not. This is the optional feature. And this WIC allows the clock of processor to be completely removed during a sleep mode. What I mean to say is this WIC is optional feature. Right? So you can decide whether to use this feature or not. And this one is optional feature. And second thing what I said is you can decide whether the clock of processor to be completely removed during, let me write here, it will decide, this WIC decide to remove the clock completely or partially. That will be defined by this WIC. So it will decide to remove the clock completely or partially during sleep mode. तुम्हाला sleep mode मध्ये if you want to save more power, WIC will decide to remove the complete clock. Are you getting? If you want to save more power in sleep mode, this WIC, if you enable this, it will remove the complete clock, or it can completely stop the clock which is provided to the processor. So this is simple meaning of WIC. And last feature that Cortex M3 supports is low power design implementation. Low power design implementation. Right. So low power design implementation is another feature of Cortex M3, since the gate count is very, very low. Gate count means the number of gates that are used in fabrication of Cortex M3. Those gate counts is very less. So the static leakage power is tiny compared to other 32-bit processors. So this is as far as design perspective or the fabrication process is concerned. We can say this thing about the Cortex M3 is the number of gates used in a Cortex M3 are low, and hence the static leakage power is very low as compared to other 32-bit processors. So this is what I would like to quote here for low power features of Cortex M3. These are the low power features. In that, I can say 2 architectural sleep modes, then 2 instructions for entering into the sleep mode. By using these 2 instructions, you can put your controller in the sleep mode. जर प्रोसेसर स्लीप मोड मध्ये टाकायचं असेल तर तुम्ही यापैकी कुठलीही इन्स्ट्रक्शन एक्झिक्यूट करू शकता. इमिजिएटली इट विल गो इन अ स्लीप मोड. देन स्लीप ऑन एक्झिट फीचर, एक्सेप्ट हँडलर एक्झिट केल्यानंतर तो परत स्लीप मोड मध्ये जाणे, याला म्हणायचं स्लीप ऑन एक्झिट फीचर. वेकअप इंटरप्ट कंट्रोलर, by using this WIC you can decide to completely stop or completely remove the clock from the processor. And low power design, since if you consider the internal architecture and internal structure of Cortex M3, it requires very low number of gates, so it reduces the static leakage power. So it is another added advantage in a Cortex M3. So these are the low power features of Cortex M3. Is that clear? Any doubt so far? Any doubt? Yes, no, at least tell something. Do you have any doubt? Sushant Aldar has left the meeting. Okay, he thought I am going to ask him a question. Any doubt so far? Do you have any doubt in the things that we have studied today, like in exception handling, interrupt handling, low power feature? Do you have any doubt with respect to that? Okay, anyways. So this one we have just now studied low power features, right? So let's move on to the requirements. Right. So what do you mean by requirement, or what is necessary things in a Cortex M3? So these things we are going to study. So in short, what we are going to study here is requirements of Cortex M3. Right? Am I audible? Hello? Am I audible? Am I audible?
Yes, sir.
Okay. Right. So we are going to discuss now the requirements of Cortex M3, and the Cortex M3 addresses or the it can address all the requirements for 32-bit embedded processor. So a lot of 32-bit embedded processors are in the market, and Cortex M3 can fulfill all the requirements which are there for Cortex there for 32-bit embedded processor, right? So how this Cortex M3 can fulfill all the requirements of 32-bit processor? There are some ways. Number one, a greater performance efficiency. What highlighting features or highlighting requirements that are being fulfilled by Cortex M3? Number one, greater performance efficiency. The Cortex M3 have this greater performance efficiency. Right. So what do you mean by that greater performance efficiency? Your Cortex M3 will be allowing more work to be done without increasing the frequency or power requirement. This is what called as a performance efficiency. Your Cortex M3 will be able to do the more work without requiring, without expecting more or high frequency or power requirement. This is what called as a greater performance efficiency. Uh, then second one is low power consumption. Of course, this is the requirement of embedded market. Low power consumption. Right. So, low power consumption, every handheld device, every small sized unit is battery operated. And when we say we are trying to build a battery operated unit, your processor that is operating that complete unit must be having some sleep modes, and it must have some low power features. Like just now we have seen those low power features, right? So, in order to ensure low power consumption, your Cortex M3 must have means your Cortex M3 is having lot of things. For example, it's having two different sleep modes, two different instructions to enter in a sleep mode. Then it's having WIC, it's having sleep on exit feature, right? So all those things will ensure the low power consumption. So it will enable longer battery life. It will ensure a longer battery life, especially critical in a portable product, including wireless networking applications. So in short, the meaning of this low power consumption is your gadget must ensure a low power consumption, must consume a low power, so that your battery will last longer, and that requirement is being fulfilled by Cortex M3, right? Next one is number 3, enhanced determinism. Enhanced determinism means what? It will guarantee that the critical task and interrupt are serviced as quickly as possible. Enhanced determinism means what? Critical tasks, interrupts, they are serviced as soon as possible, and in a known number of cycles. Means what? Let's say some interrupt is occurred and it is expected to complete, or it is expected to service that interrupt in a short duration of time, let's say in a 5 microseconds. So you can ensure that, because you have kind of good instruction set, like thumb, you have a support to the thumb instruction, you have support to the thumb 2 instruction, which is combination of 16-bit and 32-bit. You can handle complex tasks by using thumb 2 instructions, right? So that's why it is said here, your Cortex M3 can fulfill the requirement of enhanced determinism, in which critical tasks or interrupts, they are serviced as quickly as possible, as soon as possible, right? So that's why it is said it can uh, fulfill this requirement of enhanced determinism. Next one is improved code density. Improved code density means what? I just now I told you there are two types of support provided in a Cortex M3. You can have option to switch to the thumb instructions which are 16-bit, and you can switch to the thumb 2 or ARM architecture in which 32-bit instructions are there. So 16-bit and 32-bit instruction support is given in a Cortex M3. In short, whenever you require to complete the critical task, you can do it by using 32-bit instruction. And whenever you require high code density, means what? The things should happen in a minimum number of cycles. In that case, you can execute 16-bit instructions. So this is what called as an improved code density. This will ensure that code will fit in even a smallest memory footprint. मेमरीवरती छोट्या भागामध्ये सगळ्या इन्स्ट्रक्शन्स बसतील. दिस इज व्हॉट एन्श्युअर्ड बाय दिस कॉर्टेक्स M3. जिथं आपल्याला कॉम्प्लेक्स टास्क परफॉर्म करायचे असतील 32-bit इन्स्ट्रक्शन्स वापरा. जिथं कॉम्प्लेक्स टास्क नसतील, जस्ट टू सेव्ह द पॉवर यू कॅन एक्झिक्यूट द 16-bit instructions, right? So improved code density is another requirement which is being fulfilled by Cortex M3. The next one is ease of use. Ease of use, right? So your processor should be easy to use. This is another requirement from the processor. So your Cortex M3 will be providing a programmability and debugging for growing number of 8-bit, 16-bit, or migrating to 32 bits, right? So if you consider 8051, it cannot process 32-bit data. Of course, it process 32-bit data, but simultaneously it cannot process it. If you want to process the 32-bit data by using 8-bit processor, you have to do it in a 4 parts. Means what? You should process the first byte, then you should process the second byte, then third byte and fourth byte. For example, if you want to do addition of 32-bit data by using 8-bit processor, you have to add first byte of both the operands. Then you have to take the carry into the consideration. Then you have to add a second byte from both the operands. Again, you have to consider the carry. Again, you have to add third bytes of both the operands. Again, considering the carry, you have to add a fourth byte of both the operands, and then you will get the final result, right? 32-बिटची जर ऍडिशन करायची असेल 8-bit प्रोसेसरनी, तर ती 4 स्टेप मध्ये होईल. आय गेस यू हॅव डन 16-bit ऍडिशन बाय युझिंग 8-bit प्रोसेसर 8051. त्यामध्ये तुम्ही लोअर बाईट, हायर बाईट वेगवेगळे ऍड करून त्याचा कॅरी कन्सिडर करून रिझल्ट जनरेट केला होता, राईट? बट हिअर इन अ कॉर्टेक्स M3 विच इज 32-bit, तो जरी 32-bit असला तरी it can process 8-bit operations, it can process 16-bit operations, it can process 32-bit operations. So ease of use. This is what called as the ease of use. And last one is it can fulfill low cost. So it is a low cost solution. Of course, the requirement of processor, it should be low cost. So your Cortex M3 is fulfilling this requirement, and it is treated as low cost solution. to other 32-bit processors. Right, so reducing 32-bit based system cost, if you consider the cost of such a Cortex M3 is reduced. So it is very close to those legacy of 8-bit or 16-bit devices and enabling the low-end 32-bit microcontroller to be priced at less than I can say the price of Cortex M3. Rather, I should write here it's less than 1 USD. Price of Cortex M3 is less than 1 USD. Keep it in mind. What is the INR value of USD? What is INR value?
74.
Near about 74, right? So the cost of Cortex M3 raw material means only a chip, will be costing around less than 1 USD. So you can compare the cost of 8051 and you can compare it with Cortex M3. It comes with almost around same price. म्हणजे 8 बिट्सची पण 8 बिट कंट्रोलरची पण तीच प्राइस आहे आणि 32-bit प्रोसेसरची सुद्धा तीच प्राइस आहे. So this is a cost effective solution, or you can say low cost solution. Next requirement which is fulfilled by Cortex M3 is wide choice of development tools. Wide choice of development tools. Means what? To program any processor or controller, you require a development tool. You require IDE in which you should be able to edit the program. You should be able to compile the program. Then you should debug, link. Everything should be happened in this development environment. So most of the devices that you know are having one or two development tools, like your microcontroller. It can be programmed in Keel Microvision. If you are talking about a Peak microcontroller, it should be programmed with, let's say, microchip, this ID, or you can say MP Lab. If I talk about this Cortex M3, you will be able to do the programming by using Keel, ARM MDK, Keel Microvision. You will be able to program this with MP Lab. You will be able to program this. Most of the times you will find this Cortex M3 on a Arduino. So this Arduino IDE is also available to program the Cortex M3. Most of the time it can be programmed from JTAG interface. It can be programmed by ISP, which is available there, right? And simply it can be programmed through USB. So if you have knowledge of programming, you can use anything to program such kind of what you can say, a processor, right? So a lot of development tools are there, so you don't have to think about the development tool if you are using Cortex M3. So you have wide choice of development tools. So I guess you understood all those requirements. Basically, these are all requirements that are corresponds to any processor or controller, which are being fulfilled by Cortex M3, which are being satisfied by Cortex M3. All those things are satisfied by Cortex M3. So I guess it is clear requirement part, right? Next one, and important while discussing that low power feature, I told you sleep mode, right? So there are how many sleep modes? Two sleep modes are there. There are two sleep modes which are supported in Cortex M3. So let us see both of them one by one. So this is what a sleep mode. Should say sleep modes because there are two sleep modes supported in a Cortex M3. right? So what do you mean by sleep mode basically? What do you mean by sleep mode? See, in a processor or in a controller, most of the time, as I said, you have to think of saving the power. Suppose if you are having a smartwatch in which the processor is used, so the thing is, you have to keep your watch in a sleep mode. You have to keep your smartwatch in a sleep mode. मग तुम्ही म्हणाल ते वॉच तर प्रत्येक सेकंदाला इन्क्रीमेंट होत आहे, मग त्याला तुम्ही स्लीप मोड मध्ये कसं टाकू शकाल? एव्हरी टाइम द प्रोसेसर हॅव टू बी इन्क्रीमेंट बाय 1 second and accordingly the display should be updated, right? So let me tell you the very nice use of sleep mode is in a watch, because watch is a battery operated. तुम्ही बघितली असेल, it's a very small uh, kind of a battery cell is being used in a smartwatch, and still we can get a backup around let's say 3 month, 4 month, or sometimes if you are having a good quality of battery, the battery of Cortex M3 will last for 1 year. So how it is possible? Because the processor that you are using in a digital watch is kept in a sleep mode. आता मला सांगा, घड्याळाचा प्रोसेसर स्लीप मोड मध्ये कसा टाकता येईल? आपल्याला माहित आहे प्रत्येक सेकंदानंतर तो इन्क्रीमेंट होणार आहे, त्याचा जो लास्टचा डिजिट आहे तो इन्क्रीमेंट होणार आहे. मग मला सांगा, एका सेकंदामध्ये किती मायक्रो सेकंड्स असतात? 1 second is equal to how many microseconds? Can someone respond to this? 1 second is equal to how many microseconds? One second is equal to how many microseconds? Can someone respond? Can someone tell me the answer? 1 second is equal to how many microseconds? Okay, I guess everyone is in a sleep mode. They are saving their powers. So 1 second is equal to 1000 microsecond. आणि आपल्याला टास्क काय कंप्लीट करायचा आहे डिजिटल वॉच असेल तर एका सेकंदानंतर जो लास्टचा डिजिट आहे ते अपडेट करायचा आहे. यू हॅव टू इन्क्रीमेंट इट बाय 1. म्हणजेच काय, इन अ स्मार्ट वॉच you have, in a smartwatch, keep it in mind, you have 999 microseconds. You have 999 seconds, 999 microseconds for which your processor is ideal. Right, so you have 999 microseconds for which processor is doing what? Nothing. Only 1 microsecond is used for incrementing that last. Only 1 microsecond is being used to increment that last digit of a second. मग आपण काय करायचंय, वी हॅव टू कीप दिस प्रोसेसर इन अ स्लीप मोड फॉर 999 microseconds. Your processor will be in a sleep mode for 999 microseconds, and it will be wake up only for 1 microsecond. After that, immediately it will went for next cycle of sleep mode for 999 microseconds. This is how the power is being conserved in smartwatches, right? So that's why the sleep mode is important. So going back to the point, sleep mode, as I said, there are 2 sleep modes supported in a Cortex M3. and those two sleep modes are: number one, normal sleep, and second one is deep sleep. Normal sleep and deep sleep mode. Right, so these are the two different sleep modes supported in Cortex M3. Both are used to save the power, but normal sleep will save a little power. Deep sleep will save a good amount of power. Now let us understand the difference. But before that, the exact meaning of behavior of those two modes depends upon the implementation of microprocessor, how you program it. Right, now let me tell you the meaning or difference between these two. Normal sleep mode means it will switch off. It will switch off some of the clock signals. It will switch off some of the clock signals. It will not switch off all the clock signals. It will switch off some of the part which is not being utilized. Suppose you are using serial transmission. So in that case, you don't have to use the parallel communication. You don't have to use the, let's say, timer operation. So you can switch off the clock which is given to those internal functionalities. So it will switch off some of the clock signal. So in that way, you can save some amount of power. What do you mean by deep sleep? It will reduce voltage supplied. It will reduce the voltage supplied to memory block and it will switch off the additional components. It will switch off all other components. Meaning of that, so in short, I can tell you the meaning between normal sleep and deep sleep. Normal sleep means you are simply cutting off the clock signal. Deep sleep means you are cutting off, or you are detaching the clock signal, as well as you are reducing the voltage which is supplied to different part of that Cortex M3. Right. So in deep sleep mode, you can save more power. So depends upon the functionality, depends upon the requirement. You can use the these two types of sleep modes which are supported in a Cortex M3. Now I have already told you there are two ways to go in a sleep mode. There are two instructions to go in a straight sleep mode. One is wait for event, and second one is wait for interrupt. WFE or WFI. Right. So if you want to execute the exceptions, if you want to handle the exceptions, you can use first instruction to put your processor in a sleep mode. If you want to handle the interrupt, you can use second instruction, that is wait for interrupt. With the execution of those two instructions, your Cortex M3 will go in a sleep mode. Right. So the processor can exit the sleep mode, and it can, if the event is occurred. प्रोसेसर स्लीप मोड मध्ये जाईल आणि जर तुम्ही WFE एक्झिक्यूट केली असेल तर इट विल लुक फॉर द एक्सेप्शन हँडलर, अँड इफ यू हॅव एक्झिक्युटेड WFI इट विल वेट फॉर द इंटरप्ट आल्यानंतरच तो प्रोसेसर वेकअप होईल. राईट. सो ड्युरिंग डीप स्लीप मोड the system clock can be stopped, but the free running clock, or you can say input, it could still be running to allow the processor to be wake up by an interrupt. Right. So the two sleep modes are as like normal sleep and deep sleep. So this is what the Cortex M3 possess, or Cortex M3 have. So to decide which sleep mode is used, NVIC system or nested vector interrupt control is there, right? So it will decide which sleep mode is to be executed, right? So that's all about the sleep mode that we have in a Cortex M3. Right. So I guess it is clear what are sleep modes, how they can be utilized in a Cortex M3. If you want to save more power, you have to use a deep sleep mode. If you have to execute a normal, so you can simply switch off the clock signal supplied to the different part of Cortex M3. Right. So these are different sleep modes. Right. So if I go back, the sleep mode is done now. Right. So this development of low power application that we will discuss in the next lecture. So with respect to snake and ladder game, or with respect to snake game, I will try to explain this concept, development of a low power application, right? So we will stop here for today. If you have any doubt, you can ask. Otherwise, we will stop here. If you have any doubt, you can ask. Otherwise, you are allowed to leave this meeting now.